Good afternoon, class. So hopefully you've gotten all your packets and you have your pens ready, and we're going to get started on 3.6. This is the last section in your packet there. Let's see if I can get that zoomed correctly. All right, so our objective here is to graph lines and write the equations in slope-intercept form and point-slope form. We're going to classify them also then as parallel, intersecting, and coinciding. We did this, at least the parallel and the perpendicular before. So let's take a look at there's two forms of lines that we're going to look at today. The two that we're going to look at today are the point-slope form and the slope-intercept form. Hopefully this will be ringing some bells, or it'll come to mind like, hey, I did this last year in algebra, because you did. So let's first take a look at our point-slope form. So point-slope form. Is when we've got a point x1, y1, and we have an m as our slope, and this is the formula that we're going to use for the point-slope form. Y minus y sub 1 equals x minus x sub 1. Then the next one that we're going to look at is the slope-intercept form. So we've got slope-intercept. And this is the line y equals mx plus b, where m is the slope and b is the y-intercept. Now b is going to be the y-intercept, which means it's going to be the point 0b. It's going to be where it crosses the y-axis and the x is 0. Now, a special one are our vertical and horizontal lines. So x equals a is a vertical line because it's going to come through. If here's x equals 5, it comes through like this. And so this is the x-intercept. And then we're going to say y equals b, where b is the y-intercept, and that's going to be our horizontal line. And we've got this little remember thing that helps us remember if it goes through a point, that y-intercept contains that point and the x-intercept contains the point 0a. Let's go ahead and do some writing of equations though, so that we can see how we work these. The first one, it says write the equation of the line with a slope m through the point 3, negative 4 in point-slope form. So point-slope form is y minus y sub 1 equals m times x minus x sub 1. So this is my x sub 1, this is my y sub 1, and this is my m. So I'm going to just substitute those values in. I get y minus negative 4 equals 6 times x minus 3. You can simplify that. We're not going to move things around. The only thing I'm going to simplify is this part. So I'm going to say y plus 4 is equal to 6 times x minus 3. And that's in point-slope form. This next one asks for it to go through these 2 points, and we want it in slope-intercept form. So that's going to be y equals mx plus b. So let's first find our slope. I'm going to do x1, y1, x2, y2. So it's going to be 2 minus 0 over 1 minus negative 1. I get a 2 in the numerator, a 2 in the denominator, which gives me a slope of 1. And I'm going to pick either one of those. I like this one. So I'm going to do y minus 0 is equal to m, which is 1, times x minus a negative 1. I'm going to simplify this, and I'm going to simplify that. Anything minus 0 is itself. So y equals And I don't have to write that 1 times anything as itself. So y equals x plus 1, because when you subtract a negative, it's the same as adding a positive. So when we have the equation of the line with an x-intercept of 3, 0, that's the point, or intercept of 3, that's the point of 3, 0. And the y-intercept is going to be 0, whatever that is, negative 5. So, and it wants it in point slope form. So that's going to be y minus y sub 1 equals m times x minus x sub 1. And it doesn't matter which one of these points you use. I will probably use that first one. But let's first find our slope. We have negative 5 minus 0 over 0 minus 3, which gives us negative 5 over negative 3. We're going to simplify that to 5/3. So I'm going to use this point. I'm going to have y minus 0 is equal to 5/3 times x minus 3. And I can simplify that yet a little bit more. Y equals 5/3 x minus 3. Okay, I've got a couple here that I'd like you to try. Remember, a slope of 0, that's still, just write it as m is equal to 0. I want you to pause the video and try these. Now that you had a chance to try it, let's take a look at example 4. We do have the slope is 0, and we want it in this slope-intercept form, y equals mx plus b. So I'm going to use this point. I'm going to put it first in point slope form. Y minus 6 equals 0 times x minus 4. Well, 0 times anything is 0, so I get y minus 6 is equal to 0. But I want y all by itself for this form, so I add 6 to each side. I get y equals 6. On this example 5, you have pretty much the same thing. You first have to find the slope. So if I take 2 minus 2 and then negative 3 minus 1, I get 0 over negative 4, or slope is 0. And I want it in this form, so I'm going to pick, let's just pick this one as my point. So I'm going to go y minus 2 is equal to 0 as my slope times x minus 1. Well, 0 times anything is going to be 0. So y minus 2 is 0. You add 2 to each side and you get y is equal to 0. Let's go ahead and turn the page over, and we're going to do some graphing. Okay, so example 6 gives us y equals 1/2 x plus 1. This is in that form of y equals mx plus b. So my slope is 1/2. Remember, that's going to be our rise over the run. And b is our intercept of 0, 1. So I'm going to start at this point, 0, 1. And I'm going to put a point here. And then I'm just going to count the slope. I'm going to go up 1 and over 2. You only need 2 points to make a line, and it's best if you kind of use a straight edge. And there's the line that you've been given, or that you needed to graph. Let's take a look at example 7. This one is given to us in point slope form, that y minus y sub 1 is equal to m times x minus x sub 1. So the slope is going to be negative 2, and my point is going to be negative 4, and you take the opposite of this sign, it's positive 3. So I'm going to start here at negative 4, 3, and put a point. And then I'm going to, this is, remember, negative 2 over 1, so I'm going to go down 2 and over 1. So I'm going to go down 2 and over 1. And I can do it a couple times if I want to, but you really only need 2. And then I'm going to use my straight edge to draw the line. When your line has only an X or only a Y and there aren't both of them, that means it's going to be horizontal or it's going to be vertical. And if you have trouble figuring that out, look at this value, this variable, that's this axis, and Y it has to be negative 3, which is right here. So if I have to cross the Y axis, I have to go across it horizontally. So this is going to be a horizontal line at Y equals negative 3. All right, why don't you try this next one, 9 and 10. Try both of those for me. Pause the video and graph these. So looking at this one, it's in slope-intercept form. So the slope is 2, which will be up 2 and over 1. And the y-intercept is negative 3 at the point 0, negative 3. So I plot that point and then count up 2 and over 1. And then use my straight edge to draw that. If you didn't get a chance to, try number 10. You can pause again if you need to. So number 10 is given in the point slope form. So our point here is going to be negative 2. Remember, you take the opposite sign, and positive 1. That's my point, and that's where I'm going to start. Negative 2, positive 1. And my slope is negative 2/3. So I'm going to go down 2 and over 3, down 2, over 3. If you run out of room on that one, negative 2/3 can also be written as 2, negative 3, so that could be up 3 and to the left, or up 2 and to the left 3. So up here and over to this point. If you run out of room on your graph, that's good to know. And then draw the line connecting those points. All right, and we're ready to move on to the last bit of our notes, the very back on page 16. So go ahead and turn your page over. And we're going to be looking at, and you did this in Algebra 1 as well, looking at a system. A system of two linear equations in two variables represents two lines. So in that system, the lines can be parallel, intersecting, or coinciding. Now, lines that coincide are the same line. Now, that same line can be written in different forms. So let's take a look at these options. We've got parallel lines. Notice that they have the same slope. But their y-intercepts are different. So different y-intercepts. If they're intersecting lines, their slopes don't match. They have different slopes. And then the coinciding lines, remember, these are going to be the ones that are the same line. They not only have to have the same slope, they also have to have the same y-intercept. So let's determine which of these we have. So let's look at number 9. We want to know if this line and this line are parallel, intersect, or coincide. Nice thing about this one is they gave them both to us in y equals mx plus b form. So this slope is m equals -3, and this slope is m equals 3. Since they're not the same, I know they're going to be intersecting. I don't even have to look at the rest of it. These are intersecting lines. In example 10, they didn't give these to us in the same form. So I probably want to put them in the same form. I really like using the y equals mx plus b because that tells us the two pieces of information we need to know. This one already is. So the slope of this one is -1/3. And the y-intercept is 5. But we have to do some manipulation here. I'm going to divide each side of the equation by 6. 6y divided by 6 gives me y. -2x divided by 6 gives me -1/3 x. And 12 divided by 6 is 2. So now I have the slope is -1/3 and the y-intercept is 2. The slopes are the same, but the y-intercepts are not. So these are going to be parallel lines. So I want you to stop for a moment, pause the video, and work out number 11 and number 12. So as we're looking at this one, we do have to do some manipulation of these equations. So I'm going to put them into that y equals mx plus b form, because that point slope form just gives me all the information I need. Add 4x to each side, you get 2y equals 4x plus 16. Divide by 2, you get y equals 2x plus 8. That tells us that the slope is 2 and the y-intercept is 8. This one I'm going to first distribute the 2, and I get y minus 10 is equal to 2x minus 2. Add the 10 to each side, you get y equals 2x plus 8. Once again, I see that the slope is 2 and the y-intercept is 8. Since they have the same slope and the same intercept, they are the same line. So take another moment if you need to work on number 12. So once again, you have to do some manipulating. On this first equation, 3x plus 5y equals 2, I'm going to subtract 3x from each side, giving me 5y equals -3x plus 2. I'll divide by 5 on each side, leaving me with y equals -3/5 x plus 2/5. That -3/5 is the slope and the 2/5 is the y-intercept. So on this one, I'm going to flip it around because I like that y being on my left side. So it's -5y equals 3x plus 6. I'll divide by -5 on each side, leaving me with y equals -3/5 y. Oops, that should be an x. I wrote that wrong. -3/5 x minus 6/5. The slope is -3/5 and the y-intercept is going to be -6/5. The slopes are the same, but our y-intercepts are different, leaving us with parallel lines. Last one, we want to set up a system for these. Erica's trying to decide between two car rental plans for how many miles will the plan cost the same. So if the cost is y, it's going to cost the initial amount plus, and I'm looking for plan A here, the initial amount 100 plus the mileage fee times the number of miles, where x is equal to the number of miles. And if I'm making an equation for plan B, the cost is going to be $85 plus 0.5 or 0.50 times the number of miles. Now in a system, hopefully you remember this, we can subtract these. So I'm going to subtract this equation from this equation. Y minus y gives me 0. 100 minus 85 gives me 15. And 0.35x minus 0.50x is -0.15x. I'm going to solve for x by adding 0.15x to each side. I'm running out of room here. So I get 0.15x is equal to 15. And then I'm going to divide by that 0.15. And so x is equal to 100. And that, remember, they're asking us for how many miles? And x was the number of miles. So at 100 miles, the plans would cost the same. Now you come down here, it says, what if, suppose the rate for Plan B in the previous example was also $35, and it's going to be per mile, not month. So suppose this one, if you come up here, was also 35 cents. Well, that's the number that was in front of x. That's our m. So if m was 0.35 for both equations, then they would be parallel lines. And we know that parallel lines never meet. And what they're asking here is, when will they cost the same? So when will they would never cost the same at any mileage, because they're parallel and they would never cross. All right, oops, never cost the same. So now you've gotten all the end of this notes, and you can work on the assignment. This is also on eCampus. You can come back and look at these notes if you need to. And I will see you on Friday. Please study hard. Thank you.